All right, so first we graph the line like that, right? Now, we're looking at that from the point 0, 0 to the point 2, 4. The x-axis and the line x equals 2. So the line x equals 2 is a vertical. So we are looking at this triangle. Find the area of that triangle. So yeah, so we have 2, 4. So our area is 1/2, 2 times 4. So the area is just 4. Now, consider the second graph. So we're going to go over to the graph to the right there on your paper, and we're going to do almost the same problem, but we're going to change it to that. So change it, instead of 2x, change it to y equals x squared. And try to do the exact same thing. So give you a second to try that.
Of the same point.
Say that again.
Is it the same point, like 2?
Yeah, so same point. Yeah, so what changes is our graph is now a parabola, right? But we're still looking from 0, 0 to 2, 4. So it's that area. Can we find the area? Why do you say no?
Because it's not like a straight line.
It's not a straight line, right? It's like curved, right? Before it was a straight line, so we had a triangle. Now we have this curved thing. How can we find the area? Key is, the only way you can find the area, you can use calculus. Can't do that with algebra. Can't do that with geometry. There's no way to find that area without using calculus. So that's kind of an example of, okay, what's something we're going to do this year in calculus that you haven't done before? Yeah, you've done like how to find the area of a triangle or a rectangle or a circle. But once you start having curved things, that you have functions and things, how do you find areas with those? You got to use calculus. Okay. So let's look at another one. So we have a cylindrical tank. Diameter is 10 meters. So if the diameter is 10 meters, we know this cylindrical tank has a radius of 5 and has a height of 20. So water is being poured into the tank at a rate of 20 meters cubed per minute. Okay. And then that is the water, I'll go green here, is filling up this tank as it is being poured in. Okay. So the question is, at what rate is the water rising? So I'm going to give you a hint in a second, but I want you to think about that first. See if you can figure out how to find that. So what we're trying to find is, if you think this is the height of the water, right? How fast is that water rising? What's the rate of that water? That water is rising, meters? It's rising 1 meter per minute, or 2 meters per minute. Or, see what we're saying? What's the rate that the height is rising? Okay. Now I'll give you a hint. Rate, right? If we find this, we're going to get our h is going to end up being our rate is going to be meters per minute, right? That's what we want to find. Okay? So here's the tip I will give you. Find what is the height, what is h after 1 minute. So if I say the tank is empty, 1 minute later, what's the height? Because after 1 minute, what's the volume going to be?
It's gonna be 20 meters.
It's going to be 20, right? So that tells you what the volume is after 1 minute. And you know the other stuff, find the height. So let's do that first. Find the height. So the trick was to consider 1 minute. So let's say we say after 1 minute. After 1 minute, we know the volume is 20 meters cubed, right? So we know the volume is 20 meters cubed per minute. So after 1 minute, the volume is 20. We know the radius is 5. And what we're trying to find is the height. Because remember, we're talking about the height of the water, not the height of the tank. The actual height of the tank here, this 20 over here, actually doesn't affect us at all, right? Is not part of this at all. It's because we're not full. If you wanted to figure out like how full was the tank and how long does it take to fill and all that kind of stuff. But we're just looking at what's the rate that the water is rising. So after 1 minute, we get this equation, and if we solve for h, that's 20. This is actually 25 pi, and you get 0.2546. That's what we get as a decimal. So the height is 0.25 meters. How long did it take to raise those 0.25 meters? 1 minute. So our rate is 0.255 meters per minute. Now, don't be scared. That's not an easy problem to do, right? The volume part's not hard. To make the jump to what happens after 1 minute is like the tricky part to get to there, right? To make it hard to understand, okay? So, let's switch it up a little bit. Similar problem, let's change it. Water is being poured in the tank at a rate of 20 meters cubed per minute. Same thing. But now our tank is a cone. Okay. Now it doesn't say it here, but we're going to keep it the same where the diameter, the radius of this cone is 5. So this is almost like the same kind of shape. But now we want to figure out, same thing, what is the rate that the height is rising? So think about it the same way as we just did the last one, and let you try. All right, I'm going to stop you there. Has anybody realized the problem with this?
It's not like the same.
What's not the same?
The diameter is not the same all the way up.
Exactly. So to before, in the last one, we knew all the way up the tank, the radius stayed the same as 5. Now, when we get down here, this radius down here where the water is not the same, is it? That changes. So what happens to the rate as you fill the cone? Think. Okay, yeah, I was going to say the opposite, but you're right. So I was going to say early on it fills faster, right? Think about it, if you had a cone and you were pouring water in, at the very beginning, at the bottom of the cone, wouldn't it fill really fast? And then as you get to the top, it gets wider, it goes slower. So because of that, the rate that the height moves changes. So we can't just find the rate changes. So when you are down here at the bottom, the rate is fast. When you're at the top, the rate is slow. And as with the last example, to figure this out, what are you going to need? You're going to need calculus. One of the big areas, one of the big first areas we're going to look at in calculus is something that deals with the rate of change. How things change over time. So when you think of calculus and think of the world, what changes over time? Like everything, right? So calculus is the mathematics of how things change over time. This kind of question, we will come back to this question later this year, and we will solve this, and I will say, and the first one with the finding the area, and I will say, hey, do you remember on the very first day, we went over a problem that we said we couldn't solve? Now we can. Now, realistically, this problem, it's going to be like November before we can solve this one, because there's going to be a whole bunch of parts to it. So as we go forward here, our whole first chapter is basically review. We were going to start off by doing some algebra review, and then we'll basically review everything from pre-calc in like 2 weeks. We'll spend like 2 days on trig and like reviewing everything, right? And we'll hit the stuff that we really need. We don't necessarily need everything from trig, but we'll hit the important stuff. You can see I got my new poster up there, right? That helps having the unit circle up there. You won't have to have it memorized as we go along. So this just kind of gets us started today by thinking about things that you look at and you're like, okay, what is calculus? It's hard to kind of explain what it is until you get into it, because it's like a whole new kind of world of stuff. But these are just two examples that kind of show you, these are the kind of problems we're going to look at that you need calculus to solve.